Can you hear me all well? This is good? Okay. So let's start it. This talk is flexible HTTP clients with STTP. I have these slides, but I'll show lots of code in the editor. We can even try to change it. Always runs wrong, but we can try. Let's get started with this. Okay. So about me, I'm Rui. I'm 31. I just realized that now. I'm a Scala developer at .near. Some of you know us. Some of you even work for us. We do nearshore projects in Scala and other languages. I'm a kind of a enthusiast for FP and accessibility stuff, actually. You can reach me on Twitter, RAGB, on GitHub also, and here, and by any means you see fit. So, the plan for today. Okay, just before that, how many people here or either don't know Scala or starting up on Scala? You can raise your hands, but someone have to count them, please. One, okay. Two, fine, that's cool. Three. Okay, so this talk is a bit aimed at people that already know Scala at least a little bit, but I'll try to use this library to at least showcase some of Scala features and idioms. Even if you don't know Scala well, at least you will see that some things are possible or some things are kind of idiomatic in Scala, okay? You don't need to understand all of that if you don't know Scala, but you just need to, see this as a showcase of Scala idioms and library design and stuff like that. So, what is STTP? These guys say that the Scala HTTP client you've always wanted, okay? This is a kind of an exaggeration, but it's probably this sentence has some truth in it. This is made by Software Mill, which is a Polish company, if I'm not mistaken, that also does Scala projects and engineering projects. They are pretty good. They work in Scala for a bunch of years, so they are trustful in this field. And I think the main author is Adam Warsky, I guess, if I'm not wrong. Okay, so really, what is that? STTP provides you a simple interface to create requests, HTTP requests in Scala, and read responses, of course, because it's kind of useful to read what you. Actually, STTP is not a HTTP client by itself. It abstracts over other more, say, low-level clients like Akka or HTTP or whatever. Lots of backends, not just for Scala, even for Scala JS, even Scala native, as you will see later on. HTTP supports streaming responses and requests, actually. Supports some facilities for testing, actually pretty simple but effective, as you will see. And I think I'll summarize it. The library is very ergonomic to use in Scala. It's very straightforward, I'd say. So, the usual stuff. HTTP, comes software in HTTP. The core library is the HTTP core thing. If you want, say, source, use the source artifact for JSON. You also need, most of the time, or at least in production, some backend like HTTP or async HTTP client from Apache or lots. You can check the website for all available backends. We will talk about some in this presentation. Okay, the imports, COM-HTTP, okay. Nothing fancy. Any question, please shout, okay, anything. Okay. First example. let us query GitHub API for my data. Okay, I just created this function called user URI, which receives a username. The first detail I want to point out is this here. Okay, the Uwharrie Macro. This is a macro. Actually, it's using the Scala string context thing, the thing that allows you to parse or process strings in compile time. This verifies that URI you're passing is correct or is valid URI in this case. So if you write something weird, the compiler will warn you. I'm just passing the path to add my these users and my username to that. The main entry point for this library is the STTP object or instance, which is actually a starting request with nothing defined. With that, I'll just call the get method, pass the this Uwharrie I defined, and I do send. Okay. And send is the thing that says, okay, I have this request, and let us send it to. That is executed. Sorry, forgot the word. The send in this case returns the response wrapped in basically nothing, because there is I imported a quick. I forgot to say in the last slide. I imported a quick object which already has an implicit backend defined, which is the default one using java.net.url machinery, the usual Java blocking stuff. Okay. And this send, you can just run the unsafe body, and then safe body is like, I don't care for errors. If you have errors, just throw exception. So running programs isn't safe always, as you see. And I'm just returning back a string because it's the default for STTP if you don't define any response type. But we can do that. So actually, I already have these user types and such defined in my scope. So if you want to see them, I can show you. But the main difference from this example to the previous one is that I'm using as JSON to say, okay, reads my response as JSON and decode that to user field. So I can read my. You can't see the code to the left. Wait. Yeah. Okay, it's fine now? Yes. Okay, sorry. Accessibility problems, as you see. So yeah, the only difference is I'm using the as-JSON combinator to say I don't want strings, I want users, and this changes the send return type. There are a couple of things that change the send return type. This is one of them. I want a response of type, in this case, user. Okay. So, this is all very nice, but what's this request? STTP is a request. This case definition, actually what request is request T, seems kind of crazy or complex, but if you look at it, you have the usual HTTP request things like methods, URI, headers, some options, but you have this weird U underscore type and the T, and this U thing wraps the method parameter, which is kind of what's going on here. Okay, this seems complex, but it's not. Actually, I'll change to my editor because it's simpler to explain. So let me show you the request T class here. Bigger, right? Fine? Okay. So, this type, UI type, means do you have a method defined yet or not? If this UI type is nothing, we don't have. If the method is defined, we have. And I can show you here. When you do say the getted, the get method, this copy thing changes the UI for ID. And ID here is kind of arbitrary because it could be something else. But if you see here, ignore the weird implicit backend and stuff for now. But if you look at this is ID in requests, this is an implicit thing that it's only defined for ID, for the ID type. And what this means is that you can only make or send a request if your request is of type ID, if your U type is ID. If your method is not defined, this doesn't happen. So what is going on here is that they are constraining the way you can call this send method with, say, domain invariants. You cannot call execute an HTTP request without a method, for instance, or a method and an Uwharrie, in this case. You can call it without anything else. Like we don't need headers, you don't need response type because there is a default for string. You don't need anything. But if you don't have the method in your UI, this send method with this implicit here prevents you from calling it. It doesn't compile, actually. If it doesn't make sense what I'm saying, please, I can explain. What? So this is the method I was talking about. One other important thing here: you can only execute or send requests with an implicit backend in scope, and this backend has this another weird type like R underscore, and the R underscore, actually the U underscore is also the same thing. It's not a simple type; it's what's called a higher kinded type, which means okay. It's a type that you can fill something in this underscore thing. It could be R of ints, R of strings, R of whatever. Okay, this abstracts over these kind of types like future, try, stuff like that. In a funny way, I'm not using future or try or anything yet. I'm using ID, and ID is kind of the simple type. Is not. It's just strings or ints or users or whatever. There's nothing wrapping it, but there is a trick here. That's a trick. We can define ID as this. ID A is same as A, so you can fool the compiler. For simple cases, you don't need anything wrapping your thing, but you need this support, so you just fool the compiler, saying that ID of A is same as A. So ID of A is a higher kind of type or a type constructor, but it's also A, which is, it's a, trick, I guess. So, talking about backends, we are using the HTTP URL backend, which, just uses Java machinery, but you already have others, like I said, HTTP, async, HTTP client, fetch, which is for fetch backend, which is something from 47 degrees to use on Scala JS. I'm not sure if it runs or not on JVM, I think so. And we have libcurl backend, which runs on Scala native, and it's pretty cool, but I wasn't able to make it work for this presentation, sadly. But it's it's C code, basically native code, so you can use curl. So, using a different backend, you just defined a different backend, and if you look at what I'm doing here, I just defined a different backend. I just did almost the same API call, and my response was magically wrapped in a try. It is that R thing. Basically, the backend, the implicit backend you have in scope, influences the return type of the send of your request. Okay, you don't need to pass any type, anything to the send. The implicit backend influences that. Okay, this try URL backend is just a HTTP URL backend we were using, but wrapped in a try thing. I can even show you the code, which is, I'll show you later because I have this there. So, by the way, on unsafe body just throws the error part away, okay? But the body, even if we can parse a response, I mean, even if you don't have any timeouts or no exceptions or whatever, even if you get something from the client, from the client, sorry, from the server. It can be, say, a 44, 500, something else. And the left side of this either thing is the error. By default, it's a string, and by default, everything that is not a 200 status response would be wrapped or would be parsed as a string, but you can change that, and you can even change on what codes the parse error or parse success part would be called. This response call, like I used, like as JSON, will be only used for successful responses. So that's the difference between body and unsafe body. You can look at the types to see what's going on. So STTP uses a bunch of interesting Scala patterns. I think most of you guys that work in Scala daily know this, but this is more for people starting out. I included these here. So higher kinds that I already explained what are these F underscore things. Okay, these are fancy names, but are just types where you can fill in, say, holes. Okay, this is just a single element type constructor, but you can have like 2 holes or even more. But they are not as common as this question mark syntax. I think I put it here. It's this kind projector Scala compiler. Okay? It's not Scala standard syntax actually. Yeah. Okay, so STTP uses this type class pattern or concept, or we're going to call it in Scala, and it defines its own, in this case, monad error. And monad error is a thing that for some F, basically for using an F in STTP, you need a unit method which put some value in the F context. You need a map, which basically maps a function over F, a flat map. If someone doesn't know this concept, please shout. I can explain it much more in detail. Okay, but basically, for those Fs we use on STTP clients and stuff, we need these methods. Like, we need to be able to map functions, sequence operations in the F context, and throw errors, or at least put errors in the F context. Okay. So let's go for an example. I will try, I hope successfully, to create gists in GitHub with this STTP client. Okay. So a GitHub API, it's like RESTful. Yeah, I know that it is a GraphQL API these days. Anything? No? What? Yeah. Okay. Sorry. Okay. RESTful is authentication or authorization. Yeah, basically a common API we all have to integrate, or this or GitLab or whatever. They all work similarly. I'm using just for authentication. I'm using just a basic one. I'm not using OAuth or anything fancy like that because it'd be impossible to show here. Okay, JSON, stuff like that. So let me show code, which is the best thing in the world to show. So Zoom is fine. Okay. So let us start from the basic infrastructure on creating, say, an API client for creating and getting gists, and then a small command line tool, actually. So first things first, we need to create or at least encapsulate all the logic for calling this API. So I need a get and a post method, which is basically what I'm using it. So this class needs 2 things: an authorization type, which I'll show you, and the backend. And we'll use this backend to do the calls. So these decoders are for JSON stuff. These monads comes from the backend, and I will use it for using the flat map. So my base request, I'm not using the STTP request directly. I'm just adding or wrapping it with authorization. And authorization is basically this. Where is that? here. If I'm using basic type authorization, I will just wrap this request with the basic authorization, and I'm using no authorization, I will just, just the identity function actually. I need to implement OAuth and stuff like that, but it's too much for this. Sorry. So for instance, how to implement a get method? Say get something from GitHub. Okay. Get is generic on T, the T type, and only T types which have a source meaning this JSON library decoder in scope can be used for these calling these methods. I will pass an Uwharrie and I return an f of T. Okay, and this f is completely generic. Could be ID, could be try, could be future, could be something. Okay, so basically I'm doing a similar thing with like what I did in the first example. I'm just as response get Uwharrie and send, but I'm fat mapping it with this or decode response thing, which will be able to decode my response, and if there are errors, throw errors. There is a decision here, which is I could return, say, the error or successful response in an either type. I did choose to basically put errors in, say, exception context. Like I don't care much for exceptions or for errors in this case, but I will throw them to the error part of the F context. If they're available for ID, we'll just throw an exception. For try, will fail with an exception. For future, will be future fail, etc., etc., etc. Post is the same. Like I'm just passing the body. I need an encoder, just an encoder for the body, but it's the same. This decode response is crazy. Basically, what I'm doing, I'm trying to parse the left side as a source error, or a GitHub error, which is also JSON. But if I can't, I will just wrap this in an unparsable JSON exception. But it's great. Don't take like many things on this. The important part is this fold thing, which is here. So if it's error, I will throw in the error content of this monad. If it's successful, I just do unit. So it's basically parsing a response to return an f of t. Nothing fancy. This is the authorization. Okay, this is the basic HTTP client I'm using, and I will use this to implement Gists API. Yeah, I need these, right? More or less, what? Huh? Boa. Nice? Okay. So what this thing needs say this implicit let me digress a bit for a while. In Scala, when you use classes, we are not using classes like Java classes for having state. Okay? We are using this for having a set of methods with a set of common, say, dependencies. Okay? These classes have no state or anything. Even the request, I didn't talk about it. The request is like completely immutable. We copy things. We don't change requests in place, or any like common Scala object in place. We do copies. Okay, this is Scala idiom, functional programming common idiom, just for sake of reference. So in this class, I need the API URLs, which is a model basically defining default URL and stuff like that, and I need the HTTP clients. I just defined the base gists URI from the GitHub base URL. So, and I define these create gist method or whatever you spell it. This is basically straight GitHub API. You need a description, a public field, and a map of file names to files structures, which I can show you even. And if you look at the method, it's like post. Okay, my the Scala type inference can understand what I'm doing. I don't even need to pass anything to the post method. The type checker can infer. And basically, I'm just wrapping the HTTP client here. It's completely dumb, I'd say. This sort of thing. And how can we? By the way, let me just. The structures I'm using is sorry. Basically is. So, NuGet request, gist file is just like a content and file name. Basically, they're models basically copied from another GitHub library from 47 degrees. I didn't even write this myself. And how can you use it? This code is very complex. It shouldn't be, but sorry. But the initial idea was trying to use different backends like Scala Native and this one. So this dependency injection cake pattern sort of madness. But they are just modules defining a backend and authorization, say, Git, stuff like that. Okay, Git, basically wiring the app. So I need the backend, I need the authorization. So I'm retrieving my credentials from variables. So more, and I'm just parsing command line arguments. First one is the description, then the others would be file names. I can even run this to try to create something. Yeah, do you want me to try? So nice. I don't know. Este? Não. Como é que isto faz, Sofia? É no botão? Yeah. You need Okay. So you are picky with these kind of visual things. Huh? So let me just... And then you can see how Scala is fast. Starting up. This is all very fast. Yes, so lots of plugins and shit. So, let me try to run this. Say Scala Meetup. Scala Meetup gist or whatever. No. Oh, is. Não interessa. And I'm just passing my, say, build.sbt file and can be something else, like another file, whatever, project, dependency, I don't care, just with this file. Let me try this. Okay, it seems it should be available, right? Something else. Do you remember the link for this thing? Let me try. / It's this, right? Sorry, I have this created word there. Sorry. This is also an accessibility showcase. This. I have to what? I can't, this is not reading the characters. Wait, sorry. Yes. Sorry.
Assistente Sofia.
Sorry.
Diz-te que eu sou a tua lovely assistant.
This is the lovely assistant. She's telling me that. I didn't invent this thing. Já tá? Why? Didn't work. It's there? Okay, it works. It seems to work. So yeah, it is not a lie, at least. Uh, yes. So I could have used, say, Scala Native or another backend. Probably Scala Native would run very much faster than this. But this will be like a short-lived, say, sort of. Where I'm now. Hey, sorry. Yeah, wait. Okay. So I already showed this. For now, interesting stuff for now. So, how can we get logging working, for instance, in this STTP? We don't add logging for like, we can add on those methods, but we can just wrap a backend, say a backend in a logging backend, and I just redefine the send method wrapping. This is an OO pattern. I think it's decorator, maybe delegate some stuff. I don't remember the name of this pattern. Basically, you decorate some say object with the same interface but with adding behavior. Basically, it's how you do logging in STTP, or how do you do another things. For metrics, any ideas how to do that? Huh? Yes, same thing. So they already have backends for Prometheus written in this same way. There is a thing you can add to your request, which is a tag, which is a completely opaque string, at least from STTP perspective. You can use that for metrics, for instance, and it's quite straightforward to use. I actually implemented this for common. It's like say 10 lines or 12 lines, something. It's pretty easy. Yeah. So other ways of other examples when using this decorated pattern, like handling redirects, for instance, trying retries. You can have a wrapper backend, completely generic backend with a retry for gets and puts and idempotent methods. And for tests, the same thing, implicit backend, but this backend is not a real one. It's a backend you can say create for each test, and you just say, okay, for this request I respond with this, for the other request I respond with that. It avoids usage of, say, things like wiremock, which I really like actually, but yeah, it avoids this complexity of setting up a dummy server for your tests, for instance. You don't want to do, say, real HTTP requests in your unit test, at least. Integration tests probably, but in unit tests I don't think so. And you basically define a different backend. It's just the same. You have backends for synchronous, asynchronous stuff, a couple of things. I advise you to take a look at the STTP website, because they have all this stuff defined there. So it was fast, I'd say. Conclusion. So STTP was yeah. Conclusion. That's nothing more, nothing much to conclude, or what I want you to take from this presentation is, like, STTP can be a very interesting library when you want to define your HTTP client, at least the client side of your APIs, the APIs used, in an abstract way, because sometimes you need, for instance, to use different backends. Like we, for instance, have to use Arc HTTP and PlayWS in different projects, but we need the same requests and response and decoders, or you need to wrap your backends with logging and stuff like that in a, say, generic way. STP would be great for that, and the API is pretty simple and pretty safe and pretty well integrated with Scala. It supports streaming, like with FS2 or Monix. I really like this library. I really recommend you take a look at the source code, because it's not that crazy, say, ZIO or IO sort of performance-related code in a type-safe way. This is even not as pure FP as some other libraries, but the code is very interesting. It teaches you very good idioms in Scala, and not such a complex as you might think at first place. So credits for this, the STP. authors, GitHub for S library, this Reveal.js slides thing, Pandoc, and .near. We are hiring actually. If you want to know more, just ask. So, questions. You can make questions now. You can ask me on Twitter. Any questions? Anything? I have lots of things I can show. So, if you have any questions. No questions. So, wait. For the really important parts. We are hosting again the LX Scala conference. This here would be called. It will be called LX Scala Interactive. It will be 4-5 of July. Today's workshops and talks. This here we have not only just pure Scala, but a reactive sort of concept. We also want talks about reactive systems and distributed systems and streaming and stuff like that. We want either Scala or reactive things. Also DevOps, big data stuff, Spark, whatever. Our CFP is open until 1st of May. And there is the website. Anything, just ask me or Svea or anyone else from .near. Be aware of tickets in a few days, I guess. Few days, yes. So early birds would be fun. Would be in the summer in Lisbon. So hope you will be there.
You have a question?